Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will see a question on from the paper M1 42 code 9709. It is A-level mathematics, February-March 2024. Okay, so this question has multiple concepts. It is work energy power, it has resolving forces, it has Newton's second law of motion. So it's a good question. So let's see here. I have highlighted all the key points. So talking about a car of mass 1800 kg is towing a trailer of mass 300 kg. I have drawn the diagram here. The whole question is changed into this diagram. So you can see it here. If I do not read the question and I just see the diagram, I can see here that the driving force of the car is 3000 Newton. The car is experiencing a resistance of 800 Newton. The trailer is experiencing a resistance of F Newton. The mass of car is 1800 and mass of trailer is 300 kg. After that I have resolved. So the downward force because of the car mass is 18,000 sine alpha, and because of the trailer 3000 sine alpha. So this is whole I have done reading the question. I would recommend the same to you. Always draw the sketch immediately. So first part of the question is saying find the acceleration of the car and the tension in the tow bar. So when it is talking about car only, it means I will consider only this part of the diagram. So when I apply Newton's second law of motion for the car, forward force minus backward force. What does it mean? Forward force is 3000 Newton. This tension in the tow bar, this resistance, and this force due to mass, which is 18,000 sine alpha. So these three are backward and one is forward. Because when you're applying Newton's second law of motion, you talk about resultant force. The resultant force you get after doing all this addition subtraction. So you can see here I have written here, and mass is 1800. There are two unknowns in this equation. One is T and one is A. So I will get only one equation here. Sine alpha is 0.05 given to you here. So I am using this value here. Okay. So now I need another equation so that I can solve them simultaneously. So the other equation I have gotten from trailer. So now which part of the system I will consider? This part. And exactly same forward force minus backward force. So I'm applying here forward force is T, backward force is due to resistance and due to mass. So I have mentioned it here, you can see here. Now, once you have written this, you have to simplify. Sine alpha is 0.05 and F is given to you here in the question. So I'm using this value. Okay. So now simple substitution, nothing else. And then I will solve equation 1 and 2 simultaneously. Okay. So now when you will solve simultaneously, I don't think I need to explain at this point how to solve simultaneously. I use substitution method. You can use elimination method also. Choice is yours. And then get the value of acceleration and tension in the tow bar. Okay. So now part B. This is how it is done. Don't forget to write the units along. Part B is talking about that the entire work done due to the resistance force experiences by trailer F is what? 6000 J when the car and the trailer has moved how many meters up? 50 meters up on the road. So I have drawn that part of this sketch here separately to make it understand better. Now the trailer and the car we will consider as a system. It's not like the separate thing. The both of them when we will cover 50 meters, that point we are talking about. So suppose they both were here at this point, and you can consider right now the distance between them is negligible, right? Because we are taking this as a system here. It will cancel out. So you just consider it as a whole. So question is saying very clearly use energy method. right? Because otherwise you can use constant acceleration method also, but we will use here energy method. It is limited. So now when we are using energy method, first of all we need to understand what is the requirement, and then we will move on. So energy method is basically when the journey starts at this point, what was the mechanical energy? It should be equal to the mechanical energy here at the end when the trailer and car has covered 50 meter. So we are talking with respect to car here, okay? But it doesn't mean we are ignoring trailer. Try to understand here. When you are going from here to here, when car covers 50 meter and when trailer come here, car will be here. So actually this distance is 50 meter. This is what we are talking about. Okay, now, so mechanical energy is actually what? Kinetic energy plus potential energy. So at this point, the reference point we will take as height 0, and when it will reach here, the height will be considered with the help of this. And I hope you understand with the trigonometric ratio. If this is 50 meter and this is alpha, it was given to in the question, then this height will be 50 sine alpha, which you will use in the potential energy formula, which is equals to 2.5 meter. So we know the height when the object will reach on the ramp after covering 50 meter, and we know initially also. So now coming back to this, mechanical energy is actually kinetic energy plus potential energy, okay? And kinetic energy here will be what? Half mv square, and velocity is given to you in the question. But potential energy will be 0 because height is 0 at this initial point here. Now what I have done here, what is this? When we write plus minus work done, if because of some force the energy is increasing in the system, we write it plus. But if work done is done to overcome some frictional force, it means energy is minusing from the system, so we write it with minus sign. So these two work done are against frictional forces. This is on the trailer and this is on the car. And what is the definition of the work done? Do you remember? Force into distance. So force of friction was given to you here in the question. You can see here 800 was car and F was trailer, and F was, we will see what was F. So now we know work done is equals to force into distance, so we will use that. And car driven force is 3000. So we can easily fill up these things. Now we will see how just in the next line. Give me a minute. And then kinetic energy here again, half mv square, and potential energy is mgh. Now the velocity here at this point and the top we have to calculate. This is what the question is about. Okay, let me clear it up, these things. So that we will keep as it is. Okay, just 1 minute. Too much writing on the board actually confuses the students, so that's why I hide the rest of the lines. Now I'm plugging in the values. You can see here very clearly this will be 0 because of height. Here I will write what I will write 20 square, and mass is given to me for the trailer and the what? Car together, because you're considering it as a system, so it should be together. Okay, and work done by engine was 300 Newton multiplied by distance, because it is force into distance. So I'm simply plugging in values now. This was given to you in the question straight away, 6000. Here, work done by the force, total work done. So I have written 6000 here. Just a minute, let me erase this. And then it is work done against car resistance. Again, I will use the formula force into distance. Here, 800 into 50. And then this H we have just calculated here, 2.5 meter, and V we have to calculate. So this is what I'm going to substitute values now. You can see here in the bottom. Okay, So 2100 is coming because of the total mass of car and trailer, which is here. And this is M. It is 2100 and G is 10, and that's I multiplied, so it will become 21,000. After that, I'm doing nothing, just solving it. You can use calculator yourself and get the value of V. So this is how you will calculate the velocity when the car will cover 50 meters up on the ramp. Thank you very much for watching. In next question, I will solve question number 7. Next video, sorry. February, March 2024, this question. Again challenging. You will find the link in the description below. So please press like and subscribe button and share it with